Hello, my friends. Welcome to my lesson. Let's take your coffee and we'll start together. Yes. Now, our topic is lossless data compression. This is all about just think you have a file. So all the things in the computer like file, but just think you have lots of words there, and or just think about DNA. There is we have adenine, guanine, thymine, and more. So it's taking lots of place like that, So it's like 6.5 billion million DNA have there, and you have to store it in computer. It will take lots of place in your computer, but uh, let's try their comparison. I mean compression with some algorithm. Run length algorithm have this is working for images, maybe icons. You can think like 16 by 16 icons, but just think about text or letters. So how you can compress them in the one place and with the small of data. So we are using compression data, right? For that compressing. Anyway, we have two kind of data. First one is lossless data compression, and we have lossy. So it's two. Okay, let's start with the need for compression, and just we will write lots of things together. Thank you. Let's start to write it. Anyway, I'm coming here. That's good. Let's close this place. Yes. Now let's say modern computers can store can store increasingly 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 large numbers of files, but file size but file size file size still matters, of course. And the smaller the smaller our files are, the more files the more file files we can store. Yeah. So let's come down, and we use compression. So let's write compression. Yes, algorithms to reduce the amount of space needed to represent file. Okay. Now, just what I want to tell you, I will notate you it. It will be good, I think. Let's try with what, I know I will do it with the rectangle. Yes. So what I'm saying here, just think, let's do it white and maybe make black. Why? We can use black. Okay, let's duplicate it and come here and just make small it like that. Yeah. So what I'm saying here, with the example, I mean, just think like that. Oh, this is also black. Let's do it. Um, let's do it white. Say white. Yes. Okay, let's think this is our file. Okay, and this is file, and this is also file. This is small file. The other one is big file. Okay, so let's say this one is 50 kilobyte. This one, let's just write more place here. So yes, this one is 20. So here, the important point, we just compressing this data, the 50 kilobyte data to 20 kilobyte. So if we want really, so we can arrange it for without so without losing real information in our files, so we can export all of our information in good way. Just we using some algorithm for solve this problem. That's right. In two way we are working with the files. So about compressing, let's come here and say we we say here there are two there are two types types of uh, compression. Yes, we have compression. Okay, this first one is lossless and lossy. This one is lossless, other one is lossy. Okay, so we have really too much critical points here for solve this problem with uh, without losing any data. I mean, real data. Anyway, let's say this one is can be. Uh, let's make this color, and for that one we can introduce same, so we can implement same. Okay, let's come down and first let's speak about lossless. Okay, so in that way I will just write it. That's from here. Let's say lossless. I will plot below it. Okay, lossless compression algorithms reduce the size of files without without losing losing right without losing, yes, any information in the file, which means that which means that means that we can reconstruct the original data. Let's spread it. Original data, mm, from the compressed file. Yeah, the other one, mm, lossy. Lossy, lossy. Okay. Lossy compression algorithms. Algorithms reduce the size of files. Reduce the size of files. Files. Mm-hmm. By discarding. Yes, this is the important point. Discarding discarding less important information, less important information in a file, in a in a file. So, which means that we can, so no, in a file which can significantly, significantly, right? I don't know how to use it. Which can significantly reduce file size, but also affect file quality. But also affect file quality. Right. So this is the two important point here. Now what I want to do, that's this lossless. Put in this place. So just I want to notate it. Uh, this one is like that again. Okay, this is like that. So what is different between lossless and lossy? So lossless is just you don't gonna lose any information in your file. It's just you exporting what you need, all the things going in the same time. So just you compressing your file. Just think there is some words reducing. Some words is recurring all the time. It's just think like we have ladder A, too much recurring in the sentences, and just you're compressing it. So you're tagging in the one place and you're using only one thing for represent this A. I mean, you're not going to write lots of time this A with the bits. I mean, okay. Anyway, I will show you this data. Yeah, let's come down. Now we will say we will first explore lossless compression. Lossless compression techniques. Yes, that work for yes. Now, I just want to do one thing here. We have four topic here that work for what, the first one is text documents. Text documents. Documents. The other one, simple images and all binary data. Simple images and all binary data. The other one will be uh, lossy compression techniques. Lossy compression techniques. Okay, so what is that? Lossy compression techniques. for photos and audio. Anyway, this is our four. You can say simple images and all binary data. So you can think, okay, this is some three topics. Okay, we will do together, and we will go deep of them, and we will solve all this problem together. I told you so. We will explore lossy compression techniques for photos and audio. Okay, let's first. We will start with the lossless text compression. I mean this one, first one. Okay, let's come down and let's say here lossless text compression. This one. And tag this one in the red and just plot below it. Where is that line? Let's come down and let's plot it. Okay, this is our topic now. Let's start to write and we will go with our all details. How can a computer compress text? How can a computer compress text? Compress text. Here's here's a hint. Say lots of people compress text. Lots of people will compress text every day. Every day. When they are writing text messages, when they are they are they are mm, when they are reading reading text reading text messages and they don't want to type. They don't want to. Yes, put there. Don't want to type. They don't want to type a lot. Okay. So now we will understand this detail. Let's come down and let's say, for example, if uh, I want, say, I want, if I want to say like greet, see you later. Yes. So I could type type like what, like this. Let's come here. Maybe you can take a little bit left it. Yeah, it will be like that. Look at that. Great. See you later. Here and here. The the important point here. Let's look at great. It's this word. So in this place, it is just recurring again in the later. In later, what we have 8 and 8. It's so have you see these details here? You're just compressing it in the one place. So computer just doing it for make little bits of little bit area, little bit space of the store your data there. So you can say I shorten it. That text, the text by looking for by looking for looking for repeated sequences. Yes, and replacing those sequences with shorter with shorter sequences. So what is here important point? You know that this is 8 and ooh, yeah, this is. So did you understand? Maybe you will say, hey, why U is already there for this place? So just if you think a little way how we can represent them in the small piece of data, so we can use some algorithm like that. But anyway, we will speak about this algorithm. Okay, let's start compression algorithm. Okay, let's say let's come down. Yes, say compression algorithm. That. Okay, now our first topic in lossless text compression. Let's make this one like blue, some kind of color like that. Yeah, so maybe we can do something like that, but maybe let's change color to make it like that. Yeah, I love this color because okay. Now we will start to write here all of our information. Yes, let's start to write it. Let's come here. Yeah, let's say, uh, right, computers can compress, computers can compress text in a similar way, text in a similar way by finding repeated sequences, by finding repeated sequences, yeah, and replacing them with shorter and replacing them with the shorter with the shorter representations. They don't need to worry about the end result. They don't need what is that? Don't need to worry, worry about the end result, about the end result, sounding sounding the same, sounding the same, right? Yes, like people do, like people do, like people do, right? So they compress even, so they compress even further. Yeah. Let's try it with this. It with this cut from cut from William Shakespeare. Shakespeare. Yeah. Let's say this one is like to be or not to be. To be or not to be. That is the question. That is the quest. That is the question. Now, if you check it, now you will see two is same, B is recurring, or no, or is not recurring. Two recurring, B recurring, not recurring. That is the question. The other one's the same. Now, to be and this to be, we can represent with the things. Anyway, let's look at that. We don't need to write. So I mean, I'm speaking about computer. Computer don't need to write lots of time this to be or not to be like that for showed us. So it will do something background with the algorithm algorithm. So let's come here. Say the most obvious repeated obvious repeated sequences are I told you to and b, right? So the computer could represent them with the represent them with the with the with the character that isn't part of that isn't part of isn't part of the original text, like the original text, like okay. So let's come here. Now I will show you what I'm saying here. Let's uh, text the pencil, and I want to do something here. Let's say, oh, this is white. Let's do it black. Okay. So I'm speaking about this, but maybe I need little. Uh, anyway, yeah. this, and let's say we have this. I think I can do it with this one very simple why I'm trying it. Yeah, really. Let's come and do it like that. Yes, do it black. Yeah, let's do it little bigger. Maybe little down. Okay. That's again line. Take line. Let's do it. This. The line can be, where is line? Yeah, the line can be white. Okay, this one here, and we need also something like that. Uh, that's I don't want to interest with this things really. This is making me too much tired. Mm, let's copy also one more. Mm, just take the place of it, little this area. Why it's looking like that? I don't understand why. Uh, okay, let's tag it back. It's looking very bad. Mm, it just I want. Let's take this, duplicate them, take down, and let's draw them to the um, how we can. My brain stopped with this. I don't understand really. Just tag this one here and really this one there. Okay, this will be something like that. It's really making you tired. Yeah. And you want to say here or not again. It will be like that. Then let's tag it and let's do, but before do it, let's in this and just I want to tag it. It bring there and let's mm, that's what we did need to do, and just take this one, bring here my, yes, take this one. In your life all the time the small piece of things making you too much busy with, oh, with thing. Anyway, Let's do it black this place. mm, this is black, and this is also black, like that. Mm, yeah, this is that. Okay, this is good. Let's take pencil again and say here at is at is mm, so let's take this again to there. um, Not there. Let's take little right and down. Yeah, this will be here. Let's duplicate it and go right to is and say is and is and question. It's like lots of time, really. Okay, so now here what we did, to be or not to be. To be, it's be that, to is that, to that, be that again, not, so this place to be or not to be. Then to, this one is, I mean, we take from that to, I mean this to, and from do we take again do. So let's look at here. This one is representing that is to, is the, and it's same again. It's recurring there. So we are just representing with the things like that. Okay. So this is important point here. Uh, so just don't forget it. Okay. Now let's say the computer also the computer also needs to store the table of replacement that is mode, so that it can reconstruct the original. Yes. So what we can say here, let's come down and I will show you one detail here. Just tag this piece of information and really, yes, just tag them and bring them down. Now we will use them again. Like what? Like that. Let's wait me. So let's say for this place, this is replacement and this original. Okay. And just plot something here. Okay. Let's do it step by step. Let's tag this to, it will be there. Yes. And the first one, yeah, let's bring it here. second one will be here. The third one will be here. Yes. Now let's write here. Maybe we can write here, right? And no, it's not good. Yeah, just come here and really go right side. Not maybe we can change it. This is really not too much difficult. What is it? There. Just slide it. Oh no, come back. This is what there. Let's bring it back. Yeah, this thing here, I don't know what is it. Yes, anyway, let's delete it. Let's come right. This point, it will be 2. Other one will be B, and the last one will be Z. Let's take this, bring here, and we know what they are representing, right? So you can check it. Now, I will ask a question in the same time. Maybe we can for check our information if it is true. Okay. Let's say check your understanding. Okay. For indicated, for notate good, let's do this color. Then let's come down and see if you can find, see, no, what is that? Oh. See if you can find, if you can find ways to compress this verse, compress this verse, verse from factor says. Yep. So now we will look. It's saying I am some I am. At okay, let's yeah. Let's do it in here. It will be good. Let's say this one is like I am some. Some I am. That some I am. That some I am. Okay. I do not like that. I do not like that. Some I am. Do you like green eggs to hum? Do you like green eggs? Green eggs and ham? I do not like. I do not like them. I do not like them. Them. Some I am. I do not like green eggs and ham. Okay, this is the from Dr. Seuss. Oh, we can say which sequences could be replaced, compress text, say, choose all answers that apply. Down. Okay, let's say the first one we have A. A is just question mark. B is like some. C is like. D is like you. E is like M. F is like eggs. Okay, let's solve it together. We have I am some, it's not some, it's some. Let's say this is some. Yeah, some is recurring. Some is recurring. I recurring. M recurring. So let's take this one. So green. The question mark is just one time repeating. It's not. Because we are looking which sequences could be replaced to compress the text. We are looking for that. The sum is really true answer. Let's make it like that. Why it's wrong? Yeah. Anyway, the sum is true. Then we have like. Just like is recurring lots of time here. Have you see? Like is too much there. And we have some and some here. All the time there is lots of some. So this is like true, some true. How much we have you? This first one. Then we don't have you divided. So we have m. M is recurring too much with the some I am some, something like that. It's turning m is too much there. This is true. Yep. And then we have not eggs. It's just eggs. Let's look at there. Eggs is just one time. It is not true. It's wrong. I think you got it, right? So we can represent our recurring text with this something. So just be compressing text file. Let's do this one. Not eggs, it's like eggs. Okay. Mm-mm. Now we have also, so I think we can tag in the place also this information. Let's text m is true. Let's go up and like is true and sum is true. Okay, true answers is there. Well, let's say compression amount. Let's say let's speak about capability now. So what we can compress and what we cannot. So for what we can't implement that. So how? So just just see what we are doing here. That's important. Mm. Yes, let's come here. Up here. Let's start right there. As you as you can see, as you can see, some text compress it down. Some text compress it down quite a bit, quite a bit. More repetition means more repetition means means more compression, more compression. Some tags can't be compressed at all, like the alphabet. Yes, this is important, like the alphabet. How you can compress alphabet? This is really not possible, believe me, because all letters different. They are not recurring in the alphabet every time. Those are really different. So let's look this example. You know already, like we have A, B, C, D, E, F, G, H, H, I, J, L, K, L, M, N, O, P, Q, R, S, T. I hope I didn't wrong. T, O, Y, X, Z. Yes, I mean that. It says unique. So I mean, in alphabet, each word, so each letter is unique. It's not looking same, right? So for that, we're saying, in fact, in, let's make them small. Let's say, in fact, compress it, a compressed version of the alphabet, of the alphabet may take more bytes, may take more bytes to represent than the original and the mm, original version, depending if the algorithm if the algorithm puts additional meta metadata in the file. So important point, just think like that. Can you think of other examples? Can you think of other examples of text that wouldn't wouldn't get smaller from compression, for from smaller from compression? So what about examples that would what about examples that would compress really well? What do you think? Do you have some idea about that? If you have, just write comment. Okay, let's say we are okay with the fact that compression compression doesn't doesn't guarantee to a smaller file file size overall. Most files to contain most files to contain has to contain repeated repeated sequences and to benefit from compression. Okay. Also, I will tell you, if you want to learn more about uh, what is that? If you like to learn about this type of about this type of compression, you can research. You can research the Lampel Lampel Ziv Welch. So this one is like LCV algorithm. So we did use here LZV, this Lampel-Welch algorithm. Okay. Yep, this one. Yeah. The now other topic will be lossless image compression. Okay, we will do it together. Okay.